Good afternoon, sir.
Good afternoon.
Good afternoon, Professor G. Sudarshan Reddy, sir, Secretary cum Correspondent, RBVR Women's College, Dr. G. Achuta Devi, Madam, Principal, RBVR Women's College, and dear participants. I welcome you for this online 1 week International E-Symposium on modern mathematics.
Good
afternoon, madam.
Good afternoon.
Now we'll start with a prayer song. For that, I just call upon, yes, Satvika, BSc second year student, RBV Women's College, to render a prayer song.
Om Gam Ganapataye Namo Namah. Om Gam Ganapataye Namo Namah. Gajavadana Gananatha Prabhu. Gajavadana Gananatha Prabhu. Sankataharana Bhavabhayaharana. Sankataharana Bhavabhayaharana. Veda Vidayaka Modakasta. Veda Vidayaka Modakasta. Vidyadayaka He Mama Bandhu. Vidyadayaka He Mama Bandhu. Gajavadana Gananatha Prabhu. Prabhu. Siddhi Vinayaka He Gunadam. Siddhi Vinayaka He Gunadam. Vigna Vinashaka He Rampa. Vigna Vinashaka He Rampa. Mangalarupa Pavana Nama. Mangalarupa Pavana Nama. Lambodara Jaya Dina Dayala. Lambodara Jaya Dina Dayala. Gajavadana Gananatha Prabhu. Sankataharana Bhavabhayaharana. Veda Vidayaka Modaka Hasta. Veda Vidayaka Modaka Hasta. Vidyadayaka He Mama Bandhu. Gajavadana Gananatha Prabhu. Prabhu. Thank you.
Thank you, Satvika, for a devotional prayer song. I request Dr. J. Achuta Devi, Madam, to tell about our college to the audience.
Hello,
Good afternoon, Priya Hassan, Madam.
Hello.
Can you hear me, Madam?
Yes, I can hear you. All. Good afternoon, everyone. I welcome all the participants to a 1 week International E-Symposium on Modern Mathematics. I would like to extend a special welcome to our resource person, Professor Priya Hassan, Madam, Manu, Hyderabad.
Thank you.
Let me speak a few words about our college, Madam.
Yes.
Our college, that is Raja Bahadur Venkatrama Reddy Women's College. It is established in 1954 by Hyderabad Mahila Vidya Sangam. It is a non-profit educational society with a vision to empower women especially those from rural areas. The college owes its existence to the foresight of Sri Rajabahadur Venkatrama Reddy, Kotwal of the erstwhile Hyderabad state, who believed that modern education is the most appropriate vehicle for emancipation and advancement of women. His vision was translated to reality by the untiring efforts of Sri Burgula Ramakrishna Rao Garu, the first Chief Minister of erstwhile Hyderabad state, Sri Madapati Hanumantrao Garu, former Mayor of Hyderabad and Chairman of the Legislative Council Andhra Pradesh, and Sri K.V. Rangareddy Garu, former Deputy Chief Minister of Andhra Pradesh, who were the pioneers in propagating women education in the state. This legacy of noble service to women education has been continued by successive managements comprising of judges, professors, and other people of eminence in the field of education. The college has a history of being raised by eminent dignitaries. The college has a rare privilege of welcoming Pandit Jawaharlal Nehru, the first Prime Minister of India, who laid the foundation stone on 3rd January 1954. Dr. Sarvepalli Radhakrishnan, former President of India, inaugurated the college building. And Srimati Indira Gandhi, former Prime Minister of India, inaugurated the hostel building. The visit of Dr. APJ Abdul Kalam, former President of India, to address the students on the eve of Golden Jubilee celebrations is yet another landmark in the history of the college. On the eve of Diamond Jubilee celebrations, His Excellency Dr. C.H. Vidyasagar Rao, Governor of Maharashtra, visited our college. The government of Telangana, the Governor of Telangana, Her Excellency Dr. Tamilisai Soundararajan, she awarded degrees to our students in the recent convocation, which is conducted by our college. The college is recognized by UGC under 2F and 12B. It is affiliated to Osmania University, conferred autonomous status by UGC since 1989. It is accredited by A grade from 2007 to 17 and was awarded B++ grade in 2018 in the changed accreditation procedure of NAC. I hope with this E-Symposium, all the participants gain loads of knowledge, and I congratulate Sweta Srivastava and her team for conducting this wonderful program. And I thank all the resource persons who accepted our invitation. Thank you. Thank you, one and all.
Thank you, madam. Now I request Professor G. Sudarshan Reddy, sir, Secretary cum Correspondent, RBVR Women's College, Hyderabad, to address the gathering.
Good afternoon. I'm happy to be part of this inaugural session of the faculty development program on modern mathematics, being organized by the Department of Mathematics and Statistics of RBVR, or Women's College, Hyderabad. And the first speaker, I have just heard that Priya Hassan from Maulana Azad National Urdu University is here with us to speak to the participants. I hope very recently the Mathematics and Statistics Department had organized a FDP of 5 days duration, and this is a second one, maybe in a very short span of 2-3 weeks time. And this goes to show that how seriously the Faculty of Mathematics and Statistics Department, under the leadership of Sweta Srivastava, and now being guided by a senior faculty, Dr. Uma, who was formerly from University of Hyderabad, and we are very happy to have her here. And she's, I am told, is ably guiding the department to organize such events. So, as in the case of the earlier FDP, this time also I noticed the resource persons are drawn from some of the eminent institutions in the country as well as abroad, because I noticed that one of the faculty members is from a university in Toronto, Canada. The others are from the institutions, namely Jawaharlal Nehru University, Tata Institute of Fundamental Research, then University of Hyderabad, then University of Bangalore, and a couple of other institutions located in different parts of the country. And I'm very happy to hear that the students as well as the faculty, the PG students particularly, as well as the faculty, are going to benefit a lot from the programs like this. And in spite of the summer being very hot this time, and the regular teaching program being on virtual mode, this FDP is also on virtual mode, being conducted in daily 2 sessions in the evening time. And I think this will help everybody, whoever is interested, whoever is really serious about it, will surely benefit them. And I'm very happy, and I congratulate the department and its faculty for conceiving such a wonderful FDP on modern mathematics. And I hope in mathematics and statistics department will continue to organize such programs in the days to come to enrich the faculty as well as the students. I once again congratulate the department and thank them for inviting me to be part of this program on this day in this afternoon. Thank you one and all. Thank you very much. Over to Sweta. Hello.
Thank you, sir,
Yeah.
for your cooperation and guidance in conducting of this International E-Symposium, and always you will be guiding us to do all this kind of events. Thank you, sir, once again. No. I'm Ms. Shweta Srivastav, the head Department of Mathematics and Statistics, RBVR Women's College, Hyderabad, and the coordinator of this 1 week International E-Symposium on Modern Mathematics from 23rd to 28th May 2022. It's indeed my proud privilege to give an introduction of the dynamic and dedicated Department of Mathematics and Statistics, RBVR Women's College, to you all. The Department of Mathematics is one of the oldest departments, which is established in the year 1962 with the introduction of PUC. BSc Mathematics was started in the year 1965 and BSc Statistics in 1995, and MSc Mathematics was started in the year 2005. And the major milestones of our department are establishment of the Statistics Lab in the year 2000, and establishment of Mathematics Lab and introduction of practicals in the year 2005 by using the mathematical method. The department has 13 faculty members, of which one is PhD holder and 2 qualified, and 4 faculty are pursuing their PhD. The department has an experienced, knowledgeable, and dedicated team of teachers who has a vast experience and are well known for their expertise. The faculty members are on academic boards examiners of paper setters for various universities and other autonomous colleges and universities. The faculty are members in varied academic bodies like in Indian Science Congress Association, Ramanujan Mathematical Society, Bharat Ganita Parishad, AP Society for Mathematical Sciences, Mathematics Consortium, to name a few. The department offers various courses in UG like Maths, Physics, Chemistry, Maths, Physics, Computer Science, Maths, Stats, Computer Science, Maths, Electronics, Computer Science, and Maths, Statistics, Data Science, and PG in Pure Mathematics. And we also offers mathematics papers in other PG courses like MSc Computer Science, MSc Chemistry, as well as MSc Data Science. Our department has quite a few distinctions, like we are the first in the state to introduce Mathematica software as a part of practicals for mathematics students and Minitab for statistics students. We are the first in the college to introduce student projects for BSc and MSc final year students. We are the first in the college to succeed in collaborating with premier national institutes like Indian Institute of Geomagnetism, Navi Mumbai, and National Geophysical Research Institute, Hyderabad, for the student projects and summer internships. Our faculty backed first 3 prizes in postal presentation conducted by Indian Science Congress Association, Hyderabad chapter, year 2016. We are associated with School for Differently Abled Children, Manasa, under Institution Social Responsibility. We are the nodal department for certified voluntary work. And the department has research collaboration for strengthening research and student projects with Indian Institute of Geomagnetism, Navi Mumbai, and Autonomous Research Organization under the Department of Science and Technology, Government of India. National Geophysical Research Institute, Hyderabad, a constituent research laboratory of CSIR. The curriculum is made contemporary and vibrant with varied updates based on the inputs of academic and industry experts. The department adopts varied student-centric methods like heuristic method, experimental method, participative method, ICT methods, etc., so as to make learning effective and fun for the students. The department uses varied information and communication technology tools like Google Classrooms, Zoom app, Google Meet app, etc., which has come as a big boon in the social distancing and lockdown time, which has helped the teachers to take online classes and interact with the students. The department has contributed to the research and has undertaken varied academic extension activities. The department is known for varied academic and extension activities it undertakes. Some of these are seminars, faculty development programs, distinguished lecture series, advanced lecture series, National Mathematics Day celebration every year. Mathematics, Marx Ganana Club has been established to promote mathematics as an interesting and fun to learn subject. Our students are well accepted by the industry. They have been placed in various corporates and institutions like Wipro, Genpact, Concentric, Data Business Support, etc. They have shown their acumen by winning a lot of prizes at various events. The department is well equipped with the modern learning resources as mathematics lab and statistics lab, which are having adequate number of computer systems, both desktops and laptops, licensed software, along with printers and scanners. Lot of activities are undertaken by the department to support the student learning and growth. Varied practices has been adopted to make teaching learning effective. Now about the workshop, I just give a brief introduction for this. Mathematics describes not only this world, but all possible worlds. Modern mathematics has beginning in 1990s. From 1990, relying on set theory with the work of Cantor, Whitehead Russell. Cauchy laid foundation to analysis. Said theoretic foundation led to abstract algebra versus classical algebra. Function analysis versus classical analysis. Theoretical computer science, a new subject altogether. Precision in definitions and rigor in proofs are characteristic of modern mathematics. Interaction with other disciplines are greater now in the 21st century. Number theory uses algebraic trigonometry and function analysis heavily. Cryptography stemmed out of number theory as an application, and applications of mathematics came in a big way in this century. Topics unfolding during the week reflect the modern aspects of mathematics. The speakers cover various branches of mathematics in which advance has been taking place. Please enjoy the talks from some of the world famous speakers. Thank you. Now I request Lakshmi Prasanna Madam to introduce today's resource person for this session, Professor Priya Hassan Madam, to you all.
Thank you, Madam, for giving me this opportunity to introduce today's speaker, Priya Hassan Madam. Dr. Priya Hassan is an assistant professor in physics at the Maulana Azad National Urdu University, Hyderabad, India. Madam did her integrated master from the Moscow State University, Moscow, Russia. Madam completed PhD at Usmania University, Hyderabad in 2004. And Madam completed postdoctoral research in France and Ayuka, Pune. Madam was awarded the Women Scientist Award by DST in 2006. Madam has presented her work in various conferences in India, Europe and US, and in the United Nations, Vienna. Madam, her research interests her in observational astronomy, star formation, star clusters, and galaxies. Madam is actively involved in Olympiads, public outreach, and science popularization programs. And Madam has worked on various projects with the IAU, International Astronomical Union, and Office of Astronomy Development, US Consulate, Hyderabad, etc. Madam is the co-chair of the Women in Astronomy Working Group with International Astronomical Union. And Madam, member of the Public Outreach and Education Committee, Astronomical Society of India. And lastly, Madam also trained with the International Science Development Team with TMD. And Madam and her husband, they are educators, do a lot of extension activities, connect to schools and colleges, educating the students about astronomy. This is the brief introduction about Priya Hassan ma'am. Thank you, Madam, for giving me this opportunity. I hand over the session to Priya Hassan ma'am.
Thank you very much, ma'am, and thank you so much to all the organizers for inviting me to talk to the students, and I'm very happy to be doing that. Thank you so much. I would request you to please make me co-host so that I can share my screen. I can't, because it is host disabled, sharing of the screen. Yeah, thank you. No, pick Priya as an co-host. Madam, can you make me co-host? You make me co-host. Yeah, please make me co-host. I would request you to kindly give me permission to share my screen. I can't share my screen. Please give me permission. Hello, yeah, could you please give me permission to share my screen? Hello, could you please give me permission to share my screen?
Hello, madam. I just make you as a co-host. You can share the screen, madam.
Yeah, okay. No, it still says disabled. I think you've done it for Najib.
Okay, okay, madam. I'm just doing it.
Yeah. I still can't share my screen.
Okay, just a minute, madam. I will be making your co-host.
Najib, I've mailed you my PPT. Open it from there. I'll show from there.
Madam, I have just making you as a co-host, madam. You can share the screen.
Yeah, okay. Yeah, okay, thank you. It's done.
Welcome.
Yeah. So thank you very much. Like I'd like to repeat, thanks to the organizers for giving me this opportunity to talk to you, and thank you very much. So today I'll be talking about the rocket women of Isro. Since we were talking about women and women in science, I would closer to my area, and that's it. So first of all, I would like to show you something which probably you all have seen, but it's a very beautiful ad which is there on TV, and it captures some important points which I'd like to talk about. So I'll first show this to you. This is little Santo, a little girl who, I will mute it. So this is a little Santo who is very fascinated by Mars, and she wants to become an astronaut. So you see in this video, in this ad, while she tells her friends, parents' friends, that she wants to become an astronaut, most of them think of it as a very unachievable dream. And the girl, like you can see, is, you know, not too happy, but she's very enthusiastic about space and about research. So you see that here she has her father's helmet. Santo has a father's helmet, which she colors, and she's still very fixated to the idea of actually going to Mars. While her parents actually think that she needs to focus on her exams, on her, on her studies, because that's what she should focus on. But you can see that the father over here understands that this is Santo's dream. She is interested in this. And therefore you see that when Santo goes to school, everywhere where she goes, she keeps thinking about things about exploring Mars and various things. And she tries to do various projects at home where she makes a study of Mars. She's studying magnetism. This is a levitation toy she has made by studying magnetism. And you can see that this child is totally obsessed with this fascination of going to Mars. So when her mother comes to her room in the night, you can see she has the solar system model. She puts up the lights and there are stars which come shining up in her room, in Santo's room. And that's when the parents realize that this girl, this little girl, really is very interested in pursuing her dream of actually becoming an astronaut and going to Mars. And you see that as this thing progresses, the parents begin to understand that Santo, the little girl Santo, is truly interested in this exploration, and that's when they gift her the yoga laptop. So the ad is basically for a laptop, but it conveys very important questions that come to our mind. For example, the very question about can women do science, and how strongly society in principle even opposes women who want to do science, because they often think that that's not what they should be doing or what they are capable of. And so we come to the important question that can women actually do science, right? And if you actually see in India itself, our history, Anandibai Joshi, she was the first female doctor of Western medicine. And you see that she actually did her degree in the United States, and this was in 1886, a very long time back. But then in 1933, You see, as recently, this is not even 100 years ago, you see Dr. Kamla Soni, who was actually denied admission in the Institutes of Science by none other than our Nobel laureate C.V. Raman. C.V. Raman himself was very convinced that women cannot be doing sciences, and therefore you see that it's inherent in India and in our institutes, where people do believe that women are not born scientists. So if you actually see IISc, which is the Indian Institute of Science, which is a premier institute for scientific research in India, you see that in the 1960s only 2% of the you had students were female, and now after so many years of independence, after 75 years of independence, the number has risen to 19%, which is still not yet very good, because in principle you should have a good 50-50% divide between the male and female students, which shows you that this is still a problem which has to be very seriously handled. If you look at the global statistics, then women make up only 28.8% of those employed in scientific research, and they are less likely to enter into careers in STEM, and they are poorly represented in science academies. Only 12% of female members are present in the 69 science academies worldwide. Similarly, only 19 women have been awarded Nobel Prizes in sciences since 1901, and in the 3 science categories. And if you see, in 2018, the joint winner of the Nobel Prize was Donna Strickland. She was the first female laureate after a big gap of 55 years to actually get a Nobel in physics. And in 2020, Andrea Ghez shared the Nobel Prize in physics for her work on the stars close to the center of the galaxy. If you look at the Indian picture itself, one of the most prestigious scientific prizes which is given by the Indian government is called the Shanti Sarup Bhattagar Award, and it has been given only to 16 women out of a total of 500 since its inception in 1958. Similarly, women also receive less than 5% fellowships awarded by the 3 major science academies. They are quoted less often, and only 1 out of the Indian National Science Academy's 41 office bearers was a woman, and just 14 one of INSA's 501 awardees was women. So you can clearly see that there's a clear dearth of women in STEM in India, as well as in leadership positions in STEM. Now today I'm going to focus upon the rocket women, as I've called them, the women of Isro, and we're going to focus on their achievements to actually see how, though in Isro only 20% of their workforce is made up of women, but women have very strongly contributed to the programs of Isro. But however, no woman has reached the top rank in Isro since its inception in 1969. So that is something which we look forward to in the future, where women would actually spearhead Isro. So what I'm basically going to focus about today is about role models, because I think that's very important for our young female students, for them to actually see role models who've actually been achieving things in fields in STEM, because they could be an inspiration to our young girls, and they could also be a source of inspiration. So, but the story I'm going to tell you today is very closely linked to our space program, and therefore I'm going to start off with the inception of our space program, which was in 1969 on 15th August when ISRO was founded, and the father of ISRO was Vikram Sarabhai, and this is just a short while after the independence. So obviously the biggest question was, why does India need to be part of the space age, right? Because space is a very expensive kind of research that has to be done, and India at that time had just got its independence, and there was obviously a lack of funds, lack of potential, and therefore the big question when Vikram Sarabhai proposed the space program was, why do we actually need to have it? And that's when Vikram Sarabhai said that we are not doing our space program to actually compete with economically advanced nations, but we are convinced that if we have a space program of our own, then we can actually use it to actually develop our country, and we'll actually see how in this case, where the space program has actually helped in the development of the country, and actually in the of many disasters which could have actually hit the country, and therefore the whole space program in India was actually done for the development of the nation. It was basically to solve problems of man and society. We were not trying to fight in the the space age, but we wanted to basically use it for the betterment of man and society. So let's start with the humble beginnings of ISRO in 1961. These are very iconic pictures where you see that you have sounding rockets and various apparatus which was being used by ISRO, which was literally taken on cycles and bullock carts. And this basically shows that ISRO, as it was earlier also and even now, it basically worked on a very tight budget. They always had to work on a very tight budget, and that's when they actually, they worked on this tight budget to actually build up their things. So like I said, what were the basic ISRO objectives? You had of the development of man and society. So India actually, a short while after independence, you have 1969 independence, and a short while after that, in 1975, we actually launched the first satellite with the help of the Soviet Union, which was called Aryabhatta. And 5 years after that, India itself launched its own satellite called Rohini by the Indian-made launch vehicle, which was called the SLV, which was the Indian-made launch vehicle. And then we developed various more powerful launch vehicles so that you could continue with the space program with independence from any foreign service. And that's when they developed the Polar Satellite Launch Vehicle, the PSLV. And then we had the GSLV, which is the Geosynchronous Satellite Launch Vehicle, which was basically meant for placing satellites in geostationary orbits. Now, satellites are placed at different orbits in different heights depending upon the purpose of the satellite. For example, a surveying kind of satellite needs to be at a height of not more than 200 kilometers if you want to survey the land. But for example, if you want to actually have a satellite which is always overhead a certain place, which is called a geosynchronous satellite, it's always on top of the sky in a particular place, then you have to put it at a certain height of about 36,000 kilometers so that it rotates with the same velocity as the Earth. It will always be for that. And that's what's used for geostationary satellites, which is catering to a particular region. Polar satellites actually loop around the Earth so that they can actually scan the Earth in an effective manner. And depending upon that, you need to have the launch vehicles, depending on the kind of satellite and the purpose of the satellite. So let's start off with, we won't talk more about satellites in the sense of the other kinds, but we are going to go to the ones which are related to astronomy. So first of all, let's go to the moon. Now in 1969, the Americans already landed on the moon. You had Neil Armstrong on the moon. But in spite of that, the moon is still a very interesting object to explore. The moon is the closest cosmic body on which you can actually, which is the closest one to land on. And it's a promising test bed. And therefore, Chandrayaan, you had so Chandrayaan 2, we had Chandrayaan 1 and Chandrayaan 2. These were two missions sent to moon. And these are basically not only to stimulate the advancement of technology, but also there are many propositions of things that can be done from the moon, which is of interest to the Indian government too. So we'll start off with the first mission, which was Chandrayaan 1, where India was only the 4th country to go to the moon. And this was actually launched in 2008 by the PSLV launch vehicle, the Polar Satellite 1. And it actually carried 5 ISRO payloads. And but unfortunately in 2009, within a year's time, rather less than a year's time, there were certain technical issues with the mission, and therefore the mission was closed in this thing. But in spite of that, in the short period that Chandrayaan 1 worked, it actually found a very important finding using what is called its mineralogy mapper, which is called M3, and they actually discovered water on the moon. So the first thing of water on the moon, it was claimed by the Apollo astronauts 40 years ago, but Chandrayaan 1 actually got definite evidence of the presence of water on the moon in that short period in which it's operated. After that, we had another mission which was called Chandrayaan 2, which was the follow-up mission to Chandrayaan 1, which was in 2019, 10 years after Chandrayaan 1, which actually included a lunar orbiter, lander, as well as a rover, which you can see over here. And if you see Chandrayaan 2, let's come on to the women now. You can see that the project director of the mission Chandrayaan 2 was Muthaiya Vanitha, whom you can see over here on the left. And she was responsible for this whole project from the start to the finish. The project was almost 1,000 crores. It costed 1,000 crores. She specializes in digital signal processing, has written various books on satellite communications. So she was the project director, and the mission director was Ritu Karidhar, and she was the mission director for Chandrayaan-2. So you can see, and she was also for the Mars mission, which we'll come to in a short while. And so both these women were spearheading the Chandrayaan-2 project. So Ritu Karidhal, whom I just spoke about, she worked for Chandrayaan-2 as well as the Mars mission. She was the mission director for this. Ritu studied in the University of Lucknow, did her bachelor's over there, did her master's over there too, and enrolled in a doctorate program at Lucknow University. But then she also got an admission in IISc Bangalore, where she got a master's in aerospace engineering, and later on she was also conferred an honorary DSc by Lucknow University. So these were the people who were there in Chandrayaan-1 and Chandrayaan-2. So you can see that there was a big step up in the mission of Chandrayaan-1 and Chandrayaan-2 in the kind of science that was achieved by Chandrayaan-2. And one of the most important things about Chandrayaan-2, this was launched by the GSLV Mark II launch vehicle, and you had it launching, and you actually had a moon lander which was called Vikram in memory of Vikram Sarabhai. But unfortunately for Chandrayaan-2, Vikram, the launcher, actually failed. Some of you all may have seen it, that in the last 2 kilometers, while the lander was landing on, it was supposed to do what is called a soft landing on the surface, but in the last 2 kilometers, there was a malfunction in the final moments, and the lander actually crash landed. It did not have a soft landing as planned, and that was a failure. But the orbiter, which is there of Chandrayaan-2, is still functioning and still sending a lot of information about the moon onto the Earth. So in a way, it's still a successful mission. So like I said, that water was actually found by Chandrayaan-1 as well as explored by Chandrayaan-2 also. It also looked for various minor elements, and it actually has mapped nearly 95% of the total lunar surface in X-rays for the first time. It actually detected various materials on it and studied, and is still studying the moon in very big details. Now Chandrayaan-2 was special for a simple reason. The first thing is that it was the first space mission which actually went to the southern polar region, and it actually had all the Indian technology which was used in the launch. Now after Chandrayaan-2, the next big mission that Isro took up was called Mangalyaan. And the thing with Mangalyaan is that if you look over here down, this is the orbit of the Earth. You know the orbit of Mars is outside the orbit of the Earth. The Earth's orbit is about 365 days, Mars' orbit is about 387 days. And what you can see is that the close encounter of Earth with Mars happens every 26 months. And therefore, when Mangalyaan was planned, there was only 18 months for this close encounter. So that was the tight deadline that people had to actually make it for the Mangalyaan mission. Now the Mangalyaan mission was launched in 2013 with the PSLV launch vehicle. And the PSLV launch vehicle, if you can see, I'll show you over here. Here you know the order of the planets. There's Mercury, Venus, Earth, Mars. So that's the kind of distance which we needed to go to. And Mars has always been interesting for everyone, not only with science fiction, but even for hardcore scientists. And what you can see is that the race to Mars, going to Mars was not an easy job at all. So if you can actually see over here, USSR or former Soviet Union actually had 10 failures before they finally had a successful landing on Mars. The Americans actually had 5 failures before they landed on Mars, and therefore India in principle was the first country to land on Mars in their first attempt. Okay, otherwise all other countries always had it more than 1 failures. Like you see, the Russians with 10, the Americans with 5 failures, Japan tried it, had a failure, and there were various, there's a Chinese one which was Grunt, which actually failed at the launch itself. So you see that it was a very difficult job to be actually doing it. And when the Mars mission, or Mangalyaan, it was also called the MOM, which is the Mars Orbiter mission, it actually was launched together with another mission by the Americans, which was called the Maven Mission, which was again to Mars, again with the same deadline of reaching Mars in September 2014, because that's when it had its close passage. So Mangalyaan mission, or the MOM mission, you can see it's a very small satellite, about the size of a small car, a Tata Nano kind of a thing, about 1,300 kilograms, and that's the satellite. And here let's come to the women behind Mangalyaan. So if you see Nandini Harinath, she was actually the project manager, the mission designer, and the Deputy Operations Director on the Mars Orbiter mission. And therefore she, you can see in the picture itself, this is a very young engineer who actually had to take up this job, which was a very daunting task for her, a very difficult one. But she did it in a very good way, and it was a very successful mission. It's there on our 2,000 rupee coin. If you road note, if you see, there's the Maven Mission, the picture of it. And then you also see Meena Rohit. Meena Rohit was is a BTech in Computer Electronics and Communications from Ahmedabad, and she then joined Isro, and she was part of the Maven Mission. And you can see that she had to actually work in a windowless room often for 18 hours a day to prepare for the mission. She was also the designer of a couple of instruments even on Chandrayaan 2. That's Meena Rohit. Momita Datta is also one of ISRO scientists who was part of the Maven Mission. And one of the important things of the Maven Mission was actually to look for methane on Mars, because methane is an indicator of life on a planet. And there were various detectors on other missions too, but the one on MOM is also a very important one, which can very well trace methane on Mars, and that's what it did. The other very important, this is the MOM mission, which you can see over here. Another very important part about the MOM mission is that the launch vehicle we have in India is it cannot directly shoot to Mars. So we'll actually come out to a very unique technique which was used by ISRO to launch to Mars. But before that, we can have a look at MOM, like I told you, about 1.3 tons. And it had it had 5 instruments on board, which were basically to study Mars in more detail. We don't have the time to go into each of these, but you can find details of this probably on the net, and you can actually check on these things. Now, the important part about the MOM mission is you can see that when the Maven Mission was, the launch vehicle which ISRO has does not have the capability to go directly to Mars. And therefore what we actually did was something was called a slingshot kind of a thing. In the sense, you have the satellite being launched on a first orbit over here, and then you have thrusters or boosters on the satellite with which you increase the radius of the orbit in the second orbit, and the third orbit, in the fourth orbit, in the fifth orbit, and finally in the sixth orbit. That's when the satellite managed to escape the gravitational force of the Earth and aim directly to Mars, which you can see over here. But this is a very carefully calculated orbit. You actually need to know very well how to fix these thrusters so that finally you go there. And then when you come to this point, this is the most important point, which is the Mars insertion. At this point, you actually have to slow down the satellite so that the satellite gets captured by Mars. And that's the Mars insertion orbit. In case you have a larger velocity, the satellite will fly by. If you have a smaller one, then Mars will just gobble it up and it will fall onto the surface of Mars. And therefore you can see that in this mission, which is also called the mother of slingshots, you actually have these various slingshots, 1, 2, 3, 4, 5, and then in the sixth one you actually land up over there. But that's the only way it could be done with our PSLV launch vehicle, because PSLV launch vehicle cannot send such a large satellite directly to Mars. It does not have that kind of capacity. So once it's shed off, which is within the first 1 month, then it took about 299 days for it to reach to Mars. And then the important point is that after 200 days, after 300 days, when it reaches Mars and gets inserted onto the orbit, then the satellite has to wake up, right? It has to start off again. It has to wake up from its long hibernation and come out into operation. And therefore that was a very crucial thing. One was the crucial part of actually calculating these orbits so that it reaches Mars. The other thing is, how do you actually do the MOM insertion? And when it was inserted in the Mars orbit, initially it was behind Mars, so we could not get any signals from it. But once it came in the front, that's when they actually got signals from the satellite. And this is a very important moment when the satellite actually came from front of Mars, and that's when the signal was detected from the mission. And you can see this picture is a very iconic picture of women in saris and brightly colored saris, actually looking really jubilant about the mission. And that was the success of the Mangalyaan Mission, which was something very important and something to be very proud of. Now, if you actually look at the economics, I wanted to speak about this a little bit. Again, the same question which often people ask about is the cost of the space mission. How much does it cost us? So if you actually see, the distance to Mars is about 400 million kilometers. It costed us about 450 crore rupees to do the Mangalyaan mission. And if you actually see, it's really very funny. If you actually see, divide this by this, you will see it has barely costed India 11.25 rupees per kilometer, which is actually the cost. Instead, I think auto rickshaws now already cost more than that, and this Mangalyaan mission actually costed less than that. The American mission, which was also launched, called Maven, it actually costed 10 times that amount of money, and basically because their launch vehicle is much more powerful and it was done in a different technique. While the Indian one, with a smaller launch vehicle, we had to use some specialized techniques. And just to compare the budget which India is using on its space program, you can see that the military budget is about 2.2 lakh crores, which is the annual budget, while you can see that the budget for Mangalyaan was just around 450 crore rupees. The firecracker market in India costs about 5,000 crore rupees. The movie Gravity actually costed more than the Mangalyaan mission itself. Similarly, a movie you all could be familiar with called Robot, which was a Bollywood movie, it actually cost comparable. Mangalyaan was about 3 times the cost of that. Bullet trains will cost much more, as well as the money spent in higher education is also, this is just a fraction of that amount of money. Now, the Americans used the Saturn V5 rocket to actually launch Maven, and you can see that basically the difference in cost. I would also give justification of why does the Maven mission cost much more. That's basically because the Saturn V rocket is a much more powerful rocket than our rocket, which is the GSLV Mark III. So you can see GSLV has a barely this thing of only about 8 tons, while Saturn V is 140 tons, right? So even the reason why the Americans had to spend so much more on their mission is basically because their launch vehicle itself is much more powerful. They did use much more fuel to do that. So that justifies why they spend so much. But India, since we have a very frugal budget for our space program, we can actually compare our space program. You can see this over here, which has costed the Mangalyaan mission, which has costed obviously much lesser than the amount spent by the Americans on the Maven mission, or this is the Europeans. The Europeans actually sent a mission called the Mars Express Orbiter, which you can see is also a lot more expensive than the Mangalyaan mission. And here there's a comparison with the Japanese mission as well as the Russian mission. So you can see that the Mangalyaan mission has been of the lowest cost. It has been on a very controlled, tight shoestring budget. The other important thing that Isro has done has been in Astrosat. Yeah. It says like, hello, can you hear me? Can you hear me? Yeah.
Yes, madam, we can hear you.
Okay. So you can see, I need to mention this also, that India has a satellite which has been specially launched only for astronomy. So you can see that this is a satellite called Astrosat, which basically has 3 X-ray telescopes, SXT, LAX-PC and CZT. This is an ultraviolet telescope called the UVIT, and there's an optical one which is called the Scanning Sky Monitor. And this is the Astrosat, and you can see that the person behind Astrosat is Dr. Sita Somasundaram. She did her BSc from Delhi University, Masters from IIT Madras, and after that she did her PhD in physics from the IISc Bangalore. Now Sita has been the space mission, she led the Chandrayaan 2 mission, as well as she is the program director for the space science program and the principal investigator of Astrosat. So that's Sita. And so you see the Astrosat has made major contributions on astronomy in India, and you can see that, like I said, you have an optical telescope, you have ultraviolet and you have X-ray bands with which very important discoveries have been made. I don't have the time to go into the details of that, but you can find it on Astrosat achievements. So this is a description of the instruments which are there on Astrosat. These are the 3 X-ray telescopes. This is scanning sky monitor, and this is the ultraviolet telescope. So launch of AstroSat took place in 2015, and this was launched, this was the C30, the 30th launch of the PSLV, and it has an orbit of about 650 kilometers. It's above this thing with a slight inclination of 6 degrees. So here you have a further description of AstroSat and its telescopes, the instruments which are there on board. Like I said, I won't have time to go into the details, but these are the approximate instruments. Again, if you compare, you can actually make a comparison of the cost of, this is Chandrayaan with other important things, right? Yeah. Now, often you must have seen in the pictures that these satellites seem to be covered with gold foil. Now, it's not gold which is actually there on satellites. This is a multi-layer insulation, or it's called the MLI. And basically these are a single layer of aluminized polymidine with a silver aluminium side facing it. And the yellowish gold color of the polymidine on the outside actually gives the satellite the appearance of being wrapped in gold. But this is obviously not in gold. You can see this material over here in more detail. This is the same thing. You can see that there are layers in this, right? These are layers which actually provide insulation, because you see one of the biggest problems for satellites is the exposure to radiation which the satellites have when they are out in space, right? So what are the future plans of ISRO? So ISRO, after Chandrayaan 1 and 2, obviously like I mentioned, Chandrayaan 2 had a failure with the lander which was called Vikram, and therefore there's a new project called Chandrayaan 2, which is again planning a lander which would be a successor to the Vikram lander which failed, but which should hopefully work out. So Chandrayaan 2 will have a lander, a rover, and a propulsion module. The other important mission which you all must have heard about for ISRO is called Gaganyaan. Gaganyaan is the Indian mission of actually sending man to space, and it was expected in 2022, but the latest dates say that it's getting pushed by at least 2 years, 1 or 2 years. But this would be the first Indian human spaceflight program. If you remember Rakesh Sharma was the first Indian out in space, but that was on the Soyuz, which was done basically with Indo-Soviet collaboration. Gaganyaan is being planned to be totally through ISRO. So ISRO will launch as well as do the things. But ISRO is obviously collaborating with various countries, which include Russia, France, Canada, etc., which are actually involved in the Gaganyaan mission. There's another mission which is being planned on lunar polar exploration, on studying the poles of the moon, because we know that the poles of the moon, there is ice on the moon, on the poles, and that's what we'd like to study. A very soon upcoming mission, Aditya L1. This is a mission which will just study the sun, okay? And this was originally planned for 2022. It should go off maybe in the end of this year or the beginning of next year. This is to study the sun. And then there are a whole bunch of other ones. You have Mangalyaan 2, which is also being planned, and there is Shukrayaan, which is to Venus. That is also another mission which is being planned by ISRO to study the atmosphere of Venus. So here I have a little bit on Aditya L1. So you can see Aditya L1 is made to study the sun, and it has a weight of about 400 kilograms. It will sit at a point which is called the Lagrangian point, which is where the gravitational forces of the earth and the sun get balanced, and it will just study the sun. Mangalyaan 2, which I mentioned. So Mangalyaan 2 will be used, which will have a lander, and it will be launched by the GSLV Mark III, and like it's also with collaboration with France, and that's the thing. Gaganyaan I mentioned to you, to send 3 persons in space, of which 1 is being planned to be a woman. So hopefully one of them will be a woman. So at present, ISRO is basically working on this part of the experiment. Launching the rocket is not a difficult job. The more difficult job is getting the astronauts back. So here you can see in this picture, these are the experiments which now ISRO is dealing with, is of when this thing comes back into the Earth's atmosphere, these are parachutes, it basically will fall into the Indian Ocean, and then it has to be retrieved. And from this you'll actually get your astronauts who are sitting inside this thing. So that is what ISRO is basically focusing on, is on these, how do they get back the astronauts from this. So 2022 and 2022-3, they'll be doing experiments on retrieval of this, of the vehicle before they actually try out doing sending humans in space. So what I was trying to talk to you about in this talk was about some of the rocket women. We can call them the rocket women because they are the ones who are actually behind the space program in ISRO. Obviously there are men there too, but there is a decent, appreciable amount of women contribution in our space program. And if you actually read many of the women who actually work in ISRO, they have been very appreciative of the way in which ISRO handles their women employees. They actually say that they are treated on par with men, and that's how they are often even made in charge of various missions, which they are very proud of the success they have actually achieved in these missions. And there are some more which I should mention. There's Anuradha TK. She's ISRO's senior most woman officer. She actually joined ISRO in 1982 when there were just a handful of women engineers. She's been the project director of the GSAT-12 mission, as well as she's worked for ISRO for the past 34 years, and she works basically the key area of what are called geosynchronous satellites, okay, which are basically geosynchronous, that they lie above a certain location on the Earth. There's Valarmati, who is the project director of RISAT-1, which is RISAT-1 is the radar imaging satellite, okay, which is RISAT, and she is the first person to actually achieve the to receive the Abdul Kalam Award, instituted by the government of Tamil Nadu in honor of the former President Abdul Kalam. Tessie Thomas is actually called the Missile Woman of India because she was the Director General of Aeronautical Systems and the former project director of Agni 4 missile. So Tessie Thomas did not work in ISRO. She worked in the DRDO, the Defense Research and Development Organization. But because it's missiles in space, that's why I included her in this talk. But she's the first ever woman scientist to head a missile project in India. There is B. Kodanagoi, who is actually the group head of the Satish Dhawan Space Center at Sriharikota. She's a graduate in engineering, and she basically worked on the augmented satellite launch vehicle as well as the reusable launch vehicle. Lata Ambika is the deputy director of the Vikram Sarabhai Space Center at Trivandrum. She has a master's degree in control engineering. She joined VSSE, the Vikram Sarabhai Space Center, in 1988, and she heads the control, guidance and simulation entity at the institution, okay, at Trivandrum. And here we have a younger part of the team, Kriti Faujdar. Kriti Faujdar is part of the team that actually monitors satellites and several other missions continuously. So the satellites that are launched by ISRO have to be continuously monitored, because you can see that while they are out in space, there are various gravitational forces because everything moves in space. The Earth, the Sun, the planets, all other objects move, and therefore satellites also, they often change their trajectories because of the influence of other objects, and therefore they have to be constantly monitored. You have to monitor the satellite. The satellite has thrusters, and the thrusters are little engines with which you can kind of guide a satellite to move in a certain direction or adjust its orbit depending on what's required. So this is something which has to be done 24/7 all day for all satellites, where you actually monitor how are they moving and what are they exactly doing. And that's exactly the kind of work that Kriti Faujdar does on monitoring satellites and several missions. So these are a few of the names, and there are many, definitely many more unknown names whom I'm not talking about today. Number one, because of want of time, and number two, because some of them are unknown names, we do not know. But there are still definitely many, many more women in ISRO who are actually contributing. And therefore, I would like to conclude with one last wish, that I would say that for women in STEM or in sciences, it's basically a question of a wish. For example, a freedom of choice. I do not say that all women need to be doing science or doing STEM, but women should also have a freedom of choice in the sense, if they do want to do STEM, they should be able to do it. They needn't be forced to do it, but they can do it if they'd like to do it. And there should obviously be equal opportunities for men and women to actually do it. I would say that as a woman, I would say we do not require any reservation. You do not need to have for women. Women can definitely compete with men for positions, and they can definitely win in the competition and actually get those positions which they would like to have. I would say that we do not need any kind of reservation. Let it be where the individual is non-gendered. You look at a gender statement by Carl Sagan on why space exploration is so interesting and so important for all of us, because exploration is in our nature. We began as wanderers and we are wanderers still. We have lingered long enough on the shores of our cosmic ocean. We are ready at last to set sail for stars. And it would be best if when we set sail for stars, women and men, both of them get an equal opportunity to be part of this exploration and enjoy this journey of actually exploring space. So I would like to conclude with that, and thank you very much.
Thank you, madam,
Yes.
for readily accepting our invitation in spite of your busy schedule, and you have shared lot of information, and we have gained lot of information about this Isro, the space, Chandrayaan, everything. And now I call upon Lakshmi Prasanna for formal vote of thanks.
Thank you, madam. Thank you for giving me this opportunity. Thank you, madam. On behalf of the Mathematics and Statistics Department, it's my privilege to propose vote of thanks for this today's International E-Symposium on Mathematics. First of all, I thank today's resource person, Priya Hassan madam. Madam explained about Chandrayaan and Vikram Sarabhai space, explained about all these things, madam. So how to calculate the orbits using mathematics and economics missions and compared to 10 times of the American. So in new Chandrayaan also, so what are the studies there in Aditya, Mangalyaan, Sukragraha? So these are all you explain elaborately, madam. Thank you. Thank you for accepting our invitation, madam. My sincere thanks to Professor K. Mucham Reddy, sir, Secretary, Hyderabad Mahila Vidya Sangam. I thank Professor G. Sudarshan Reddy, sir, Secretary cum Correspondent. I thank our Principal, Dr. J. Achyuta Devi, ma'am. And I thank our Head, Department of Maths and Stats, Shweta madam, for organizing the extension lecture. I thank my dear colleagues and students for attending today's session. Thank you for giving me this opportunity. Thank you, one and all.
Principal madam as well as the branch people, sir. Okay. But afterward, this changed.
This is my duty.
Thank you, madam. Thank you for your quiet acceptance, madam.
Yeah, my
We are
pleasure.
very grateful to you, madam. Participants, if you have any questions, so that madam will be feel free to ask the questions so that Madam will be glad to explain you the cause, the doubts, what you have. Anyone? I think they are quite clear, Madam, about what you have said.
Yeah, okay. Let's hope.
Okay, Madam. Thank you, Madam. Once again,
Yes.
thank
Okay.
you, Madam, from the
Yeah.
bottom of my heart.
Yeah. Thank you. I can exit, right?
Okay, Madam.
Yeah. Okay. Thank you.
Thank you. Dear participants, please wait for some more time as the next speaker has to join the session. Good afternoon, sir. Good afternoon, sir. Can you hear me?
Yes, I can. Can you hear me?
Yes, sir.
Okay, great. Good to see you. Well, I can't see you actually. Where are you?
Oh, sir, I just.
Okay,
Yeah. Can you see me, sir?
I can. Yes, I can see you now. Yeah, good morning. Good afternoon for you. Yes.
Yes, good afternoon. First of all, for you, it's a good morning, sir. Thank you,
Should
sir.
I try? Pardon me?
First, thank you, sir, for readily accepting our invite in spite of your busy schedule and the time difference also. You have accepted this. And now I call upon Nikita, madam, to introduce today's speaker of the session, Professor Ramurthy, sir. Nikita.
Ma'am, am I audible now?
Yes, Nikita.
Okay, ma'am. Thank you, ma'am. Good afternoon, everyone. I, G. Nikita, faculty member of Mathematics and Statistics, Department RBVRR Women's College. I take this opportunity to introduce M. Ramurthy, sir. Good afternoon, sir. We are honored to have Ramurthy, sir, to give a lecture on what is mathematics and why does it work. M. Ramurthy, sir, obtained his PhD from MIT in 1980 and then held postdoctoral fellowships at IAS Princeton and ITIFR Mumbai. He was professor at McGill University 1982 to 1996 and now is Queen's Research Chair and Distinguished University Professor at Queen's University. Some of the prizes awarded to Ramurthy sir are the Coxeter James Prize 1988, Balaguer Prize 1996,
Jeffrey Williams Prize 2003, Queen's Research Prize 2003, and elected Fellow of the Royal Society of Canada 1990, Fields Institute 2003, Indian National Science Academy 2008, American Mathematical Society 2012, and Canadian Mathematical Society 2008. He received the EWR Stacey Fellowship 1991, Killam Research Fellowship 1998, and the Simmons Fellowship 2013. In 2018, he was awarded the Excellence in Graduate Supervision Prize at Queen's University. He is also adjunct professor at IIT Mumbai, TIFR Mumbai, HRI Prayag, IISER Bhopal, IMSC Chennai, and Chennai Mathematical Institute. Sir has written more than 250 research papers, a dozen books, and supervised more than 20 doctoral students, 40 master students, and 45 postdoctoral fellows. He is appointed to the Department of Philosophy at Queen's University, where he gives regular courses on mathematical logic and Indian philosophy. His introductory book on Indian philosophy has been published by Broadview Press in Canada. He is currently working on How the Mind Works According to Indian Philosophy, scheduled for release next year. Thank you, sir, for accepting our request. And I request sir to take over the section. Thank you, sir.
Thank you very much. So let me try to share my screen. I think I need permission for this. Whoever is the host, I think, has to disable the something.
Sir, I have make you as a co-host, sir. You can share the screen.
Okay, great. Thank you very much. Let's see.
Welcome, sir.
Yeah, thank you. Yeah, okay. So can you see that?
Yes, sir.
Is that better?
Yes, it's okay, sir.
Okay,
You can
great.
see your screen, sir.
Okay, excellent. Okay, thank you very much. Thank you for the invitation. So this lecture was meant to be for a general audience. Therefore, it will be extremely general, partly philosophical, partly mathematical. So let's begin with the question, what is mathematics? This is actually a difficult question to give a simple answer to. It's similar to questions like what is art or what is music? And the common reply to both these questions, what is art, what is music, is the same. It's difficult to define, but we'll know when we see great art or hear great music. And in some sense, the same thing lies with mathematics. In other words, subjective reply suggesting that beauty lies in the eye of the beholder. Now, to some extent, both these answers apply to this question, what is mathematics? But there's something far more fundamental that forces us to accept a completely different reply. And this has to do with objective truth, whatever that may mean. It's perhaps best illustrated through an example, which I'm sure all of you are familiar with, but may have not viewed it the way I'm going to present it. And this has to do with the famous so-called Pythagorean theorem. I put quotations around Pythagorean because Pythagoras really has nothing to do with this theorem, but anyway, you all know what the theorem says. You have a right angle triangle, and the hypotenuse squared is equal to the sum of the squares of the other two sides. So this is the famous theorem of antiquity. And you're all familiar with it. And we get the length of the hypotenuse with the lengths of the other two sides. Now, as we will see, this theorem was known before Pythagoras, thousands of years actually, almost before Pythagoras. Several ancient civilizations noted it. The Babylonians knew it, the Indians knew it, the Chinese knew it. So there are lots of people that knew it. And moreover, the amazing thing is these cultures, the Babylonians, the Indians, and the Chinese, all had mathematical proofs, whereas Pythagoras actually didn't. And so it's a kind of a strange quirk of history. Strange quirk of history that allows that, labeling these theorems. Usually one has to explore the history and check what the situation is. Pythagoras didn't have a proof of his theorem, but rather picked it up from his travels. Some people even say that Pythagoras traveled to India, and in fact, even to South India, where he learned of this theorem. For Pythagoras, the theorem was magic and evoked religious feelings. And to some extent, he's right. I think there's some spiritual component to this theorem, and as there is to all of mathematics. So the early history of the Pythagorean theorem, well, Babylonians, as I said, knew 1,000 years before Pythagoras knew how to generate so-called Pythagorean triples. These are integers, whole numbers, such that they're the sides of a right-angled triangle. So for example, 3, 4, and 5, you have a right-angled triangle with sides 3, 4, and 5. You have 5 squared equals 3 squared plus 4 squared. And the next triple is 5, 12, 13, and so on and so forth. The Babylonians, I think, wrote down about 100 such triples. So anyone who knows how to write 100 such triples probably knows what's going on and had an algorithm to generate all the solutions. So this is a non-trivial fact. The first legitimate proof appears in Euclid's Elements. Now, the Silva Sutras that were written in India go back to about 800 BCE, and they contain the explicit statement of the Pythagorean theorem. The Chinese seem to have a picture proof of the theorem. True, they're saying that a picture is worth 1,000 words. And it is very doubtful that Pythagoras or his school knew how to prove this theorem. The first rigorous proof seems to have been written down by Euclid 2 centuries later. So before I start these picture proofs, let me just give you an interlude on the very elementary fact that all of you know, that the sum of the angles of a triangle add up to 180 degrees. Well, the proof starts by looking at a triangle and drawing a line parallel to the opposite side, and then comparing angles. So these two angles are equal. These two angles are equal. And then adding a third angle gives you 180 degrees. So this is a picture proof, a proof at a glance. And these are the kind of things that I'm actually interested in, how to get knowledge in a single glance. All the angles of the triangle are now on a straight line, and so add up to 180 degrees. And it's a visual proof, it's geometric, and you can teach a child this proof. The Chinese proof of the Pythagorean theorem is somewhat similar to this kind of visual proof. So let's see how that works. So what they did was they took the right-angled triangle and they moved it around. So you have ABC, you move it around, and there you get a larger square. So here's the proof. Just looking at the picture gives the mathematical proof. The proof itself is in the picture. So how does that work? Well, the right-angled triangle is moved around so as to create a big square of size a plus b. Now, the total area of the big square of size of length a plus b is a plus b squared. But on the other hand, the square is composed of the rectangle inside and the 4 triangles. So the rectangle inside, the square inside has area c squared, and these each of the triangles have area 1/2 AB, and there are 4 of them, so 4 times 1/2 AB is 2 AB. Add them up, and lo and behold, you get your Pythagorean theorem. So this is the visual proof of the Pythagorean theorem. Let's contrast that. This can be also reviewed as an algebraic proof. Let's contrast that to Euclid's proof. Euclid's proof is very geometric. So he starts by I'm sure you've seen this picture. He starts by drawing various lines to the picture. Firstly, he puts the hypotenuse flat on the ground, and then he draws these various lines and essentially makes the following observations. The BAC is, of course, a right angle. CAG is a straight line. Triangle ABD and FBC have the same areas. All you have to do is rotate it by 90 degrees. This is the same area as the triangle BDL, and FBC and FBG have the same areas. Therefore, the area of the rectangle BMLD, that is this piece here, this area here, is equal to the area of the square. And by similar logic, the area of this square turns out to be the area of this little rectangle here. And that's how Euclid gets his proof. By symmetry, the area of the rectangle MCEL is the area of the square ACKH, and this completes the proof. Now, as you can see, it's a very complicated proof, much more difficult than the proof given by the Chinese. This can be viewed as a geometric proof. Now, here's the interesting thing. Here's the remarkably interesting thing. You see, the Greeks really did not have the concept of numbers per se. They were very good at geometry. Even the unique factorization theorem of natural numbers does not appear in Euclid's Elements. Although concept of prime numbers and composite numbers appear, they were very uncomfortable with the notion of a number. To understand numbers, you really have to understand zero. And as all of you know, zero is a discovery of the Indian mathematicians, and the whole theory of the decimal system and the number systems of various bases. You see, maybe you all know, of course, zero was discovered in India. You also know the decimal system was discovered in India, but you may not know that the binary system, numbers based on 0, 1, was also discovered in India. And in fact, the number system with base B for any B was actually discovered in India. So you see, this is an important discovery. It goes back very long time. Now, let's contrast that with the proof of by Bhaskara. Bhaskara, 12th century, short proof of Pythagorean Theorem. He considered the right angle triangle. Same as Euclid, he puts the hypotenuse flat on the ground, but he looks at he drops the perpendicular from C to D, and then makes a few observations. Firstly, he notices that the cosine of theta, cosine of theta is here, is equal to C minus X over B. But this triangle, ACD, is similar to CBD. Therefore, cosine of theta is also equal to the hypotenuse, the height divided by A. And so anyway, we see that cosine of theta is also equal to B over C on looking at the bigger right angle triangle. So that by looking at the cross multiplying, you see B squared equals C squared minus CX. And similarly, sine theta is X over A over C, and cross multiplying here, you get A squared equals CX. So put it back in there, and then lo and behold, you get C squared equals A squared plus B squared. Now, what's great about Bhaskara's proof is that it actually generalizes. It doesn't really need a right angle triangle. In many ways, here's another thing that's not very well known, and that is trigonometry was born in India. The whole business of sines and cosines comes from India. So the cosine law actually can be derived from Bhaskara's proof. So instead of looking at a right angle triangle, we can look at any triangle. And it turns out that if you do that, you have on one hand, A squared minus X squared is the height squared. And it's also equal to B squared minus C minus X squared. And from that, we deduce that B squared equals A squared plus C squared minus 2CX, where X is this little length. But X can be eliminated. X over A is cosine of B, and that gives you the cosine law. B squared equals A squared plus C squared minus 2AC cosine of B. So what do we see here? We see the method of generalization. So given the Pythagorean theorem, you have now a generalization. Pythagorean theorem only applies to right angle triangles. The cosine law of Bhaskara applies to all triangles. This is a very important idea. And so this is, again, a very important, why do we generalize things in mathematics? We generalize things so as to see the bigger picture, the larger pattern. So at the same time, in Bhaskara's works, you can also see what's called the sine law. The area of the triangle is 1/2 BC sine A. And the sine law, sine of the angle A divided by little a sine equals the sine of capital B divided by little b equals the sine of capital C divided by little c. This is a sine law which all of you learned in high school. It's actually due to Bhaskara. So there you go. So very little is taught like this. Now, the role of abstraction in mathematics. So I talked about the principle of generalization, but now I want to talk about the role of abstraction. So much of the process of discovery in mathematics has to do with a certain philosophical approach. And this philosophical approach is basically, what is it that we're looking at? And how have we labeled things? Is there a better way of labeling? This is a very, say, Indian philosophical tradition has been based on that. So let's see what we can learn from the preceding discussion. Firstly, an assertion has been made about universal fact regarding all right-angled triangles in the entire universe. It doesn't matter what right-angled triangle you take, the Pythagorean theorem holds. This is the source, perhaps, of Pythagorean religious feeling. Somehow you think you've stumbled on the universal truth. So in this sense, mathematics is not an art, but rather a science. It may be an art too. It may be religion too. The freedom to explore other proofs, other perspectives leads to new branches of mathematics like algebra, geometry, and trigonometry. And we saw examples of that. Even though you know a proof, you look for other proofs, better proofs, visual proofs, conceptual proofs, so that you can expand your understanding. So this is motivated by the aesthetic spirit. And so from this perspective, mathematics is actually an art. It's an art form. So mathematics is both an art and a science, and probably also a religion, who knows? The artistic component is motivated by abstraction. So what is abstraction? Well, abstraction arises from a detached view of the truth and the question, what made our proof work? See, detachment is an interesting word. It appears actually in the Indian philosophical tradition. Vairagya actually means detachment. That means Vairagya means take away your personal bias, look at it objectively, because your personal bias might be coloring the thing. So you have to kind of disassociate yourself and look at this objectively. That is really the essence, the essential meaning of Vairagya. Of course, it's degenerated into something silly, but Vairagya means detachment in this way of the word. In other words, in order to get to the truth, you have to take this detached spirit, not put your personal bias into the picture, and look at what are the key ingredients that led to the truth. So we try to isolate the parts and ask ourselves, what are they? Now, in this proof of Pythagorean theorem, the notion of length or distance is essential. We talk about the length of the hypotenuse squared is equal to sum of the squares of the length of the other two sides. So the notion of length is very important. So the question then is, what do you mean by length? Now you may say, I know. Oh no, you may not know. This is again Vairagya. Oops, I think I lost it. Did I lose something? Okay. Are you able to see me?
Yes, sir.
Okay, good. For a moment, I lost the picture. Okay, so the notion of a length is then, we're going to call that into question. So we'll use the spirit of Vairagya and to look at what do we mean by length in a dispassionate fashion. The angle between two straight lines, see the brilliance of Bhaskara's cosine law is that it allows us to talk about the angle between two straight lines using that cosine law. So the angle between two straight lines and the notion of right angle were essential. So length and angle are both mathematical concepts. And so we may ask ourselves, what do we mean by length? And what do we mean by angle? Now, in this talk, I will skip the angle part and I'll only focus my attention on length. And for those of you who are interested, there's lots and lots of things that you can explore with respect to the notion of an angle in a general sense. So the visible universe is explained or understood through the invisible universe of mathematical laws and mathematical symbols. So in other words, mathematics offers us a powerful telescope into which we can view the cosmos through symbology and mathematical theorems. So mathematics seems to be a language through which we can understand the workings of the cosmos. But it is not a language like English, French, Swahili. Maybe it's closer to Sanskrit. But anyway, it is a language of the cosmos that we're still trying to decipher. So the notion of distance and angle then, so these reflections lead us to examine the meaning of distance and angles as follows. So what do we mean really by distance? Take any set S and try to talk about the distance between the 2 points, X and Y. And we often mean that the distance function satisfies that it's always non-negative distance, yeah. And equality, the distance between 2 points is 0 if they're the same number, yes. The distance between X and Y should be the same as the distance between Y and X. And somehow the distance between X and Y is always less than or equal to the distance between X and Z, plus distance between Z and Y. Hello, could yeah, connected. So now, interestingly enough, I'm just going to say this, but I will not discuss it. The axiom B is actually interesting. You can actually drop that. Sometimes we may have what's called a directed distance. The distance between X and Y may not be the same as the distance between Y and X. This happens if you're trying to model neural networks, for example. The pathway from one neuron to another may be different from the pathway from that neuron to another neuron. So there's an interesting idea here, because again, you can drop axiom B and talk about directed distances and study a distance function in a larger sense. I will not go into the details of that, but there is such a theory that can be developed. So here's an example of a new distance function for continuous functions f and g. You may have seen I take two continuous functions and I define the distance between the two functions as the integral between the absolute value of f of t minus g of t dt. And so this opens up all sorts of metrics in different worlds. And using this Bhaskara's cosine law, for example, you can now define angle between two lines using this kind of metrization. So now I've opened this idea of abstraction, and many people say, abstraction, why do you do it? Why do we care about abstract ideas? As I said, India has been the mother of all symbology. It's all over the place. Symbology and the method of using symbols to understand the universe around us, to understand ourselves as well, has been essentially a unique contribution of the Indian civilization. And pure mathematics, I mean, even the discovery of zero, for example, when you say person who ever discovered zero, a genius who discovered zero, someone may ask, why do you care about a symbol that represents nothing? And yet we all know that the symbol that represents nothing has given rise to the whole mathematical world, in some sense, this whole entire world. So pure mathematics, abstract mathematics, has relevance even to applied math. So let me just give an illustration of this. Discussion about the value of abstract math versus pure applied math. And here's a simple example to show that both are interdependent, a very timely example. Supposing we have a virus, I just took it out of the blue, of course, this example. Suppose we have a virus that's threatening the planet, and we want to understand how do we deal with this virus. Well, a simple mathematical model says, let's say the town has n people, and at time t, the number of people infected by this virus is y of t, Therefore, the number of people not having the virus is n minus y of t. And via clinical trials, you've determined that the probability of an infected person transmitting the virus to an uninfected person is, say, lambda. So this gives us a very simple equation. Using basic mathematics, we can say the rate at which the virus is spreading is, well, y of t over n is the probability that the person has the virus. N minus y of t over n is the probability they do not have the virus. And a person having the virus meets a person not having the virus. That's the probability of is the product of the two probabilities. The rate at which the infection is transmitted is lambda. So you get this differential equation. dy by dt is lambda y times 1 minus y. Is the differential equation giving us the spread of the virus. And all of you know, using basic calculus, that this can be solved. Indeed, integrating both sides, you get log y minus log 1 minus y is lambda t plus a constant. Lo and behold, you get y of t equals y of 0 e to the lambda t over 1 minus y of 0 plus y of 0 times e to the lambda t. Y of 0 is the number of people infected at time 0. Now, what is the great value of this thing? It tells us how fast the infection is spreading. And using this, we can control the disease in some sense. This gives us an understanding of how fast the virus is spreading and can give us some control over events using basic mathematics. You see, so this is the power of math. Much of the advances that took place in the last 2 years in respect to clinical trials, epidemiology, and so on and so forth, have a lot of pure mathematics behind it. Okay. Now, let's get back to measuring distance of rational numbers. The usual absolute value, x minus y, gives us a measure of the distance between two rational numbers. But are there other ways of measuring? So in other words, are there other functions that satisfy the axioms for absolute value function? So in order to get back to our philosophical mode of thinking, we may say, what is meant by distance? Well, we want the distance or the size, length. The length has always got to be positive, except if it's nothing, it should have length 0. The length of xy should be the product of the length of x times the product of the length of y. And then we expect the triangle inequality. Length of x plus y should be less than length of x plus length of y. So this is what we mean by distance function. And we always talk about length because we visualize it. But supposing I give you a natural number, I can define another distance function actually. I can look at the power of 2 that divides n. Let's say r is the highest power of 2 that divides n. Then I can define the length of n to be 1 over 2 to the r. So in this measurement of length, the number is closer to 0 if it's highly divisible by 2. This is a new idea of distance. And it turns out that all rational numbers, now with this new definition, we can define the length of a rational number a over b, the two-adic length, as the two-adic length of a divided by two-adic length of b, where a and b are natural numbers. So we now have a length of a two-adic distance on the rational numbers. And it satisfies all these three axioms. So for example, let's look at 2048 minus 1024. The difference between the two is 1024. Well, the two-adic distance, it's 1024 is 2 to the power 10. Therefore, the two-adic length of 1024 is 1 over 2 to the 10. So it's very small. Whereas now I'm going to use the subscript infinity to denote the usual absolute value. The usual absolute values, absolute value of 2048 minus 1024, the absolute value of 1024, which is 1024. So the length, the distance between these two numbers is 1024, but the distance between these two numbers in the two-adic metric is very small. So it is just the limitations of the human being that forces us to take the definition of distance in the usual way of length, because we are visual creatures. But the remarkable thing about mathematics is that it gives us another way of looking at things, an abstract way of looking at things, which goes beyond our sensory system, which is very much what Indian philosophy was always trying to do. Indian philosophy underlined the fact that the human being is limited by his sensory apparatus, and that one has to go beyond this mental realm in order to understand fundamental truth. So this is a case in point. This two-adic absolute value satisfies all these axioms, and we come up with 2. Now you may ask the question, well, why did you choose 2? Why didn't you choose 3? And the answer is, yes, you could choose 3 too. You can choose 3, you can choose 5, you can choose 7, so on and so forth. And you can't choose a composite number. It doesn't actually quite work that way. So we can do this for any prime p. And so we can introduce an infinite number of so-called absolute values, so-called Piatic absolute values, on the rational numbers. And the unique factorization theorem now can be written as a product of all the lengths of xp's, including that infinity, which is the usual absolute value, that it equals 1. So that statement is really the unique factorization theorem. So each absolute value gives rise to a notion of convergence. So we can use, in your usual way, when we talk about the limit of a sequence on the real line, we're talking about the sequence of numbers xn going to a certain limit L, getting closer and closer in the usual absolute value. Well, we can now talk about convergence with the Piatic metric. And then, as all of you know, you complete the rational numbers with the usual metric, you end up getting the real numbers. And if you complete the rational numbers now with a Piatic metric, you get another field called Piatic field. And inside the Piatic field, there's a nice set of numbers called the Piatic integers, which plays the role of ordinary integers. Anyway, a famous theorem of Ostrowski says that up to this notion of convergence, the only absolute values that you can put on the rational number field are the usual one that we started off with, Pythagoras, length, and so on and so forth, and the Piatic ones. This is it. So you see, now we have a better understanding of what a prime is. A prime corresponds to metrization. Prime corresponds to a particular new notion of length. So the field of real numbers now become only one of a vast spectrum of fields. So when we teach kids calculus, we're talking about the real numbers. But the real numbers is only one completion of the rationals. They're an infinite collection. Therefore, we should be teaching, a new form of analysis, Piatic analysis, one for each prime p, two-adic analysis, three-adic analysis, and so on and so forth. You have to kind of, so it's as if you were only, the real numbers is only one line of a vast sequence of spectral lines. So rational numbers should really be thought of as an infinite tuple. X, where x, the first x is a real number. This x is a real number. This is a two-adic number. This is a three-adic number, a five-adic number, and so on and so forth. So all the other x's are to be viewed as Piatic numbers. And this gives rise to what's called the adelic perspective. So this understanding enables us to look at prime numbers completely differently. So what we thought we knew what a prime number was. They each correspond to a notion of length on the rational number field. And a prime number p corresponds to a Piatic metric. The usual absolute value is now treated as a prime and often called the prime of infinity. So you see, this new way of looking at things allows us to think of prime numbers are the building blocks of all mathematics, but we get a new perspective of them as a spectrum of lengths. And instead of looking at real numbers, we should really be looking at the infinite direct product, where the first component is the real numbers, the next is two-adic numbers, next is three-adic, next is five, and so on and so forth. So in this way, this gives rise to the notion of an Adel in number theory as an infinite tuple of these entries where all these xp's are in QP, but eventually we want the xp to be a Piatic integer. And why would you want that? Well, I'm not going to go into the details, but you want that because these correspond to the characters. If you know a little bit of basic character theory, representation theory, these are the characters of the rational additive group of rational numbers. Anyway, to make a long story short, I just want to illustrate how you can begin with such a simple thing like the Pythagorean theorem and start asking basic questions like what is length? What is a number? And all these very basic questions. And use vairagya, detachment. Look at it objectively, like a scientist, without any personal bias. And then come up with these new ideas. And this seems to be the Indian philosophical tradition of disassociating itself. I mean, the whole word vairagya appears as an important word, as many of you know, in the Indian philosophical tradition. It's been mutilated over time, but let's not discuss that. But the real essence of the meaning of the word vairagya means to stand apart. Don't put your personal bias into the thing. Look at it objectively. And through that objectification of yourself, you will get new knowledge. And this is the philosophy of mathematics. It illustrates the nature of mathematics and its power to enlarge our vision. There are many things invisible in our universe, but they become visible through mathematical abstraction. India, in many ways, has always adopted this view from time immemorial with its discovery of zero and the decimal system, along with other number systems. And I told you that it also discovered Piatic numbers in the context of poetry. Mention is made in the Chandogya Upanishad, for example. So we see the world only through the 5 sense organs, but that is the limitation of being human. We know that there's a larger world out there beyond the human range. That is, because we are limited by these 5 sense organs, we only see the world this way. But we have to see the world in law, and mathematics allows for that. So similarly, we've been measuring the world with only the usual absolute value, but each Piatic absolute value looks at another way of looking at the cosmos. So as an exercise, I may ask you, what is the Piatic version of the Pythagorean theorem? So you can do that maybe after the talk is over. Think about the Pythagorean, the Piatic version. So take a Piatic triangle. Ask yourself, what is the length of the other side? What is the Piatic version of Bhaskara's theorem, the cosine law? So this is really the power of mathematics. It's namely abstraction. And abstraction is very closely and intimately related to the concept of vairagya in Indian philosophy. So here's a question for you. How do we reach the Andromeda galaxy? So as all of you know, the Andromeda galaxy is there. How do we reach that? Well, it's 2.5 million light years away. And if we were to use the ordinary distance function, it will take us 2.5 million light years. However, if we use the Piatic distance, we can get there faster. It's meant to be a joke. Anyway, thank you for your attention. Thank you for the invitation, and may Ganesha bless us all with knowledge. Thank you very much. Can you see me? Hello? Hello?
Hello, sir.
Has the transmission come through completely? I was wondering.
Okay.
Was there a break in transmission?
Yes, there's some signal problem over here, sir.
Could you see the entire lecture?
Yes, sir. Just for 5 minutes, it's over. Sir, network issue over here, sir.
Hello,
Yes. Hi.
I'm Uma. you have given a beautiful talk about what is mathematics, like for those who wonder that they can't explain. It is the explanation that you have given, that it is the language, it's an art, it is philosophy actually. And coming with just numbers, you can go to Piatic, and how the whole world changes in the basic mathematics. Thank you so much.
You're welcome. Yeah. I'm willing to take questions, by the way, if there are any questions.
Hello.
Yeah, I'm willing to take questions if there are any questions.
Questions.
Yeah.
I would like to know whether this Piatic and Piatic, you have said, no, that
Yeah.
The distances made other theorems also, like Astro's case theorem, and came up with adelic numbers. And so will it change entirely the theorems that are true for real numbers?
No, the real numbers are a part of this thing.
Q infinity.
Yeah, the real numbers are a part of this. It doesn't change it, it only expands it.
Yeah. So maths actually expands. It never has a variation.
No.
It expands.
Exactly. And so whoever discovered zero, whoever discovered numbers, it still
stays.
Yeah,
it stays like that.
Exactly.
So would you think there is another planet or universe where maths could be playing a part, like signals and such things?
So that's a good question. We need something to understand the cosmos. We need some tool to understand the cosmos. Science and mathematics in particular seem to be pretty good at it. So even if there are other civilizations on other planets, they'll have to come up with something called mathematics of sorts.
Yes, I think mathematics in the form of signals only can form a kind of communication.
Yeah. So you see, the whole world is a matter of information, right? Everything, even the genes, the genetic, the cellular, it's information. There's all sorts of intelligence in a cell. Information, intelligence. So the whole cosmos is a network of intelligence.
Thank you.
You're welcome. Now I might have ended early. I ended early. I ended early because I wanted to take questions.
Thank you, sir, for readily accepting our invitation in spite of your busy schedule. And now I call upon Lakshmi Prasanna Madam to propose formal vote of thanks.
Thank you, Madam, for giving me this opportunity to propose vote of thanks on today's session. I, Lakshmi Prasanna, Department of Mathematics and Statistics. On behalf of Mathematics and Statistics, it's my privilege to propose vote of thanks for today's session. Professor Ramurthy sir. First of all, I thank today's resource person, Professor Ramurthy sir. Sir explained about today's session, the Pythagorean Theorem, the Chinese proof, how it is applicable in all different types of mathematics. Euclidean proof of the Pythagoras theorem, the cosine law from the Bhaskara's proof, the role of abstraction in mathematics, the notion of distance and angle, pure maths versus applied mathematics. In pure mathematics and applied mathematics level, how it is differ, sir is explained. Measuring distance between the rational numbers. Sir, thank you, sir. My sincere thanks to Professor K. Mucham Reddy, sir, Secretary, Hyderabad Mahila Vidya Sangam. I thank Professor G. Sudarshan Reddy, sir, Secretary cum Correspondent. I thank our Principal, Dr. J. Achita, Madam. And I thank our HOD, Madam, Department of Mathematics and Statistics, Shweta, Madam, for organizing this today's national seminar, international seminar. I thank my dear colleagues and students for attending today's session. Thank you for giving me this opportunity. Thank you, one and all.
Thank you, everyone. And special thanks to the participants for patiently listening. And today, I just wind up the session right at this moment. And we will rejoin tomorrow at 11 o'clock for the third session by Professor Sujata Ramdurai, Madam. On the topic elliptic curves and arithmetic. Please be remembered that tomorrow's session will start from 11 a.m. onwards, as there is a change in the schedule. Why? Because every day we will be starting our session from 3 p.m. onwards, but except tomorrow, that is, we will be starting our session from 11 o'clock. 11 to 12 is the third session, and the fourth session will be from 4 to 5. Thank you, one and all. Thank you, sir. Especially, I thank you from the bottom of my heart. Thank you very much, sir.
You're welcome. Have a good day. Yeah, bye.
Thank you, sir.
Yeah, bye.
Have a good day, sir.
Yeah, bye.
Bye, sir.